All right, all right. I think we are back here. How's everybody doing today? All right. Merry Christmas to everybody here. Let me go ahead and pull up the Discord and get an announcement going here. Pardon me, we're just going to get an announcement here. Oh, it's like scaling all funny. Oh, I'm trying to get the is it like kind of stretched, kind of funny? How's the resolution for you guys? Hello, are you guys there? Let me, I need to pull up the chat on my phone. I'm all discombobulated in this new setting here. Sorry. Let me go ahead and get is. How's the resolution for you guys? Hello? Okay, it's okay, I guess. It's kind of stretched because I'm scaling down. So, I need to make an announcement here. I'm so behind and disoriented today being Christmas. This be like 8:45 to maybe 10. All right. We posted that. Cool. All right. Let's get situated here. I am all discombobulated. I need to pull up my chat on my phone. Here we go. All right, I got it here. Sorry, you guys. I am so disoriented here, and I am not in my normal element. Like I said yesterday, we are at my folks' house, just um, visiting them for the holidays here. Me and my girlfriend, but we are we are out of our element for sure here. So let me just get situated. I really appreciate you guys bearing with me. I think I need to reduce size here. There we go. That's better. Then I'll actually will increase this up by to 22. All right, cool. That's better. And then let's take our terminal. Let's drop it over here. Let's bring this in like so. Awesome. And then we can disable here. Okay, let's get caught up on the chat. Airsick Titan, welcome in. Hello, hello, hello. I really appreciate you coming in. Sorry if I'm reading off my phone. Oh. Whoops. That couldn't have been good. Hopefully that didn't do any damage. No, I think we're okay. All right, cool. We are really discombobulated here. I am all over the place. Hey, Christy, thanks for coming in. Merry Christmas to you. You guys all. Merry Christmas, Airsick Titan. Yes. Learned select sort the other night on insert sort onto insert sort. Awesome. That's super cool. I'm sure we're gonna get there in our book eventually here. Just want to make sure I didn't dent my laptop or anything with that fall on my keyboard. No, I think it's okay. It's strong. Okay. Okay. Really out of my element here. All right. General Talks, welcome, welcome in. I appreciate you coming in for for Christmas here. Christy says there's a Discord bot that will automatically at the server to let them know you're live. Oh, I'll definitely need to do that. You need Nightbot. Does Nightbot, is that what you guys are referring to? Because I've been doing it manually every time now, and so it's been a little bit, no, it's been fine, but, you know, how are you guys doing today? How has your guys' Christmas been? What you guys been up to? My camera is a little bit like stretched than it should be because I am scaling the resolution. So I'm wondering if I should restart and unscale it. But I don't know. I'm not sure. What do you guys think? Is it okay? My face is a little bit stretched, so it's making me feel funny. Okay. I want to take a look at our DSA in Python again. We do need to, keep studying this. We don't want to go like a whole week without refreshing our memory on this and keeping these concepts moving. So even if we have, a short time or a shorter time streaming today, we I do want to make sure we keep at the DSA in Python to not let our learning, fade at all. So let's go ahead and pull up this guy. We'll make this half and half, and then I need to, like this. Here we go. Cool. And then let's go, and let's command, there we go. All right, so we are on problem, we are on problem 510. Scroll up here. R5-10, here we go. Or it looks like we're on 5.9 here. But I remember we got stuck on this one. We couldn't really figure it out. So I might need you guys' help with this. So let's try this one. Um, I really, the Caesar cipher, I really just don't like. I, I didn't really understand it that much when we read over it. That's why I kind of skipped these questions at first. Which I'm kind of thinking we should do it as well until we kind of can have more of a environment to really learn this. So let's try to do R511, and then let's go ahead and do this one. Let me know, guys, if the screen is all funky or if it's looking weird. I am stretched here a little bit via my webcam, so because I am scaling the resolution slightly, which I shouldn't have, looking back. No, I think it's okay. Let's make sure. Yeah. Okay. So we want to use the standard control structure to compute the sum of all numbers in n times n dataset represented in a list of lists. Use standard control structures to compute the sum of all numbers in an n times n dataset. Interesting. I'm not really sure what. Let's go chat. Okay, we have standard. What are control structures are fundamental elements of programming that dictate the flow of execution within a program. They are used to make decisions, repeat actions, and manage the order in which statements are executed. The standard control structure includes sequential control, the default flow of execution where elements are executed one after another in the order they appear, if-else statements, Okay, so it just wants us to use basic, Python functions to compute this. So we know that we need to establish like the rows and lists, which was kind of like here for the or the matrix arrays, right? Multi-structural lists, multi-dimensional data structures. So we're going to have a data variable, which is going to house a list. Inside of it, a common representation for a two-dimensional data set in Python is a list of lists. In particular, we can represent a two-dimensional array as a list of rows, with each row being a list of values. Okay, so then the list of lists is just each list represents a new row or a new line in our data matrix. So if we need to use standard control measures to compute the sum in a data set of lists of lists. So if we have, for example, a list here of 22. Let's copy that one from above, from this one, right? Here, I'll copy this here, this syntax, like so. So now we have a list of lists which represent 3 rows of data in a matrix. Knowing this, we are going to use standard control structures to compute the sum of all of the data set represented in the list. So a way that we could do this is we obviously need to, iterate in the list. So data at index value 1 is going to be a list, or index value 0 is going to be a list. We can iterate over that and sum. So let's say def sum matrix. It's going to take in some matrix here. Okay, and so we're going to say count is equal to 0. We'll say for list in data and for value in list, or for L in data and for val in L, right? We want to count plus equals to val, right? Then at the end of this function, we're going to return count. So let's call the sum matrix of the data set we have, and then let's call a print function over this entire return value. So now if we run this program, we get 3260. So let's try to see if that is correct. 3260 here. So let's take this data set and plug it here. Sum this data set. Three two six zero. Cool. Awesome. So what we had to do is we created now I will admit, you guys, this is not a very fast function. This is going to be a exponential function where we have a big O of n squared, or not exponential function, I'm sorry, a quadratic function, right? Big O of n squared, where we are indexing through every list, right? Every value in the data set, and then we're also iterating over every value in those individual lists as well. So technically have 1, 2, 3 sets of data, and each of those sets of data has 5 numbers in it. So I'm not sure how it would affect time with having lists as your data values instead of just individual data points, but Let's ask ChatGPT. Um, I wrote this function for summing, and it is correct. I am interested in understanding how iterating over lists, bring over a list of lists where those lists contain int values. How does this impact the time complexity? I think it would be in quadratic time n squared. You're correct that the time complexity of iterating through a list of lists depends on the structure of the data. Let me break it down. Iterating over a list of lists. When you iterate over a list of lists and process each element in their inner list, summing all values, you're effectively transversing all elements in the data set. The time complexity depends on the number of the outer lists, n, and the average length of the inner list, m. Time complexity analysis. If the data set has n outer lists and inner list has m elements on average, iterating through the outer list takes O of n time, and iterating through the list, iterating through elements, m takes O of m time. Since you're viewing all n times n elements once, the total time complexity is big O of n times n. This is linear with respect to the total number of elements in the data set if n times n equals big N. So, okay. Oh, yeah, that's right. So technically we're only iterating over every single element, thus having a linear time complexity. So why does this not make it a quadratic then? Is that quadratic occurs when you perform a nested iteration where the number of iterations in the inner loop depends on the size of the outer loop. Comparing all values in lists. In this case, you're processing each element in the inner list independently, so the complexity is proportional to the total number of elements, not the square of any single dimension. Conclusion. Summing a list of lists has a time complexity of big O of a large N, where large N is the total number of elements across all sublists. It is not O of n squared unless your iteration explicitly creates a nested dependency. So for list in data, and then say for val in list, is this not a nested operation? Yes, the code step you provided involves nested loops, but the time complexity depends on what the loops are doing and how the data is structured. Here's why the specific example is not quadratic but linear. The outer loop for list in data iterates over the outer list in data. If data has n inner lists, this loop runs n times, or 3 times for the 3 rows we have. Inner loop. The val in list iterates over each of the inner lists. If each of the inner lists has an average length of m elements, the inner loop runs m times. So we just run n times m, which is not n times n, right? Ah, okay. Because we're not iterating over the same n values twice, that's why we're not getting this quadratic, effect. We are iterating over a list which has 3 n values, right? We have 3 threes in our data set, so 3 rows, so that would be an n of 3. Well, we are then evaluating another loop of integers, so this would not, take in n itself, right? So this takes in some value of m for each of these. Now, if we were then to loop over all of these again and do some sort of operation, well, that would be m times m and give us m squared. So, okay. Very interesting. Make sure this is still going good. All right, yeah, still going good. Awesome. Appreciate you guys joining me this evening. For those that are new, if you're stopping in on Christmas, I'm just teaching myself Python through various mechanisms. We've been on a streak on the stream, and I did not want to end it. I wanted to hop on before the day was over for me and keep my streaming streak alive for you guys and for the channel and for the learning. I'm really, really into it and passionate. Merry Christmas to you. I hope everything was great and everyone was safe and you're able to just relax and. Um, yeah, so right now, for those that don't know, I graduated back in 2021. I have a bachelor's of science in human biology and a minor in chemistry. I currently work as a formulation chemist. I'm visiting my parents on for the holidays. That's why I'm not at my desk in my normal setup back home. But so I'm in this in the guest room here. But I appreciate you guys joining me. I've been coding for about 6 months, but I've been coding pretty seriously for the past about three, ever since September. Um, and it's been a real challenge, but it's also been really rewarding as I've learned and taught myself through these various textbooks like data structures and algorithms and Python crash course and other books that we're going to read. It's really been rewarding to go through these and teach myself and grind through them and do the practice problems, as you can see on the left side of my screen here. I know it's small. I'm on my laptop, guys. I'm not on my monitor. I'm on my actual laptop and stuff. So I'm having to cram space here, but on the left side of my screen, these are all the practice problems we've been doing so far, not even including chapter 4. Here we go. So we've done almost over like 100 practice problems so far. Getting up there, maybe not quite 100, maybe like about 50, I'd say, um, give or take. This one had 30 alone in it though, so we probably actually are looking like that's 50 right there. That's a little over 60. So we're probably looking closer to maybe 75. So really, a lot of practice problems we've been grinding through here, and getting your guys' help. So, uh, yeah, Ray Cornelius, thanks so much for coming in. Merry Christmas to you. Yes, Airsick Titan and General Talks to you as well. Thank you guys so much for coming in, and joining me this evening. And all right, let's continue on here. Okay. Have you considered doing a course on YouTube or something like Udemy? Parth Sharma, thanks so much for commenting and leaving a message. Yeah, I did. I independently did when I was first starting. Before I started the channel, I did Harvard CS50P, and that's how I initially learned Python. That was my first introduction into Python. And then I completed that over this past summer in 2024. And like I said, in August, September is when I created the channel after I completed the course. I was like, wow, I really enjoy doing this. I want to document my progress for you guys to follow along in your own enjoyment and gain inspiration or just gain companionship and camaraderie and network with me here and learn and just create a community of programmers, kind of breaking that stigma of like competitiveness and competition that I often see, and just creating a really chill, wholesome environment for us to really just focus on the learning aspects, right, and the education part. Um, and so to answer your question, but yes, so please follow along and also join the Discord link down below. I conglomerate all my study resources, and I'm also going to be hosting events located in the Discord and tracking events where we will be in 2025 Harvard CS50X. Their more full stack general CS course is revamping in 2025, and so we are going to be doing that one in just the next couple of days. So I'm going to be posting a like a thread in my Discord under the CS50X tab and channel. And so that will just have all the information about how to sign up and get started. And then we're going to, if you're going to, might as well watch me do the course, you might as well sign up and submit the work along as well and get the credit for it too, because you'll be right there doing it with me. So we're going to do that course together. And I think with our current experience in coding, yeah, we'll get some introduction into maybe some other languages, which will be nice. My main philosophy is I would like to really stick with Python for the time being, but we do need to kind of take some other courses and expand our knowledge into some other areas, and I feel like that would be a good area. And it does give you some introduction into some other languages and stuff, but we just need that more raw computer science knowledge and more full stack, because right now we're just really only we're working in a CLI. We're kind of bound in the CLI with our current knowledge. So we need some resources to kind of break out of this current state, but we also can, expand and keep going here. So we're going to be doing that course together side by side. So it's going to be really great come in 2025, the new year. I really appreciate you coming. Yeah, Rave313, what's up? I really appreciate you coming in. Happy holidays. How are you doing? So if that sounds like something you're interested in, throw the video a like, maybe follow along to the channel. We've been growing really rapidly. It's been awesome. And then join the Discord so we can track our progress together on the upcoming course we're going to take on the channel, which will be great. So yeah, and hopefully our current knowledge in Python will allow us to, and ability to code will help us, propel us through that course at a little bit faster. I'm hoping we may be able to complete it in about a month's time, which might be naive given we have a final project to complete and we're going to be learning new material. But with our current rate of study and our trajectory, I think it's a good goal that we might be able to complete maybe a month and a half at most, maybe two. So yeah, let me know if that's something you guys are interested in. I got a lot of positive feedback about that. So people seem like they're excited about that and interested in it. Okay, let's go ahead and go to the next problem here. Oh, not there. We want to make it in chapter 5, not in chapter 4. Let's close all these up. Let's go into chapter 5 here, make a new problem. R 5.12 key.py. Sorry if you hear a little vacuuming going on in the background. Like I said, I am visiting my parents for Christmas, and so there's quite a crowd that's been coming in and out, and family, a lot of family over today. So hope you guys were able to see some family this Christmas, and if not, well, we're together now, and we can hopefully mimic that same feeling. Yeah, I appreciate you guys joining here. Okay, let's go ahead and do 5.12. So the last one here, we did skip over 5.9 and 5.10. We do need to come back to these at some point. It's just this Caesar cipher class was really poorly explained in the book. In my opinion, it just it did. Sometimes the book does not do a good job of actually walking you through these at like a beginner point of view. And so the Caesar cipher that it talked about was pretty complex, and so I'm going to need to go back through and do a more deep dive into that. So I just didn't want to take up too much time today. We don't have a super long stream. Like, it is Christmas. I'm going to wrap up the evening later tonight watching maybe a movie with my girlfriend and just hanging out, eating some Christmas treats and stuff. Christy says, when you were looking for books to learn Python on your own, how did you know which books to pick up? Yeah, so I did a lot of research actually in Reddit forums. So I took a stab at the Learn Programming and the Learn Python, or Python for Beginners form or whatever, and I just did a hot search rather than trying to like ask again. You in Reddit you can just search keyword search all the past threads and get like I just searched up beginner books or books, and I kind of did a little deep dive, and it seemed like Python Crash Course, Fluent Python, DSA in Python were coming up over and over again. Automate the Boring Stuff, another no starch press publication. These ones were kept coming up over and over again. And so I said, that's probably, I take other people's word for it. I learn by example. So similar to the format of this channel, right? Okay. Describe how the built-in sum function can be combined with Python's comprehensive syntax to compute the sum of all numbers in an n by n dataset represented as a list of lists. Mm. Need to rename this guy. It's got an extra decimal here. There we go. So let's take our data set here. And if we want to describe how a built-in sum function can be combined with Python's comprehensive syntax, so if we look at our sum matrix function, can we so let me look up Give me the params of the sum function. The built-in sum function in Python is designed to sum up items in an iterable, such as a list or tuple. Yep, we know that. Okay, cool. So we have an iterable. We have a required is an iterable containing the numeric values. The element must be numbers. The start optional. What's this? What's this forward slash? Huh. What is the forward slash? The forward slash in Python function definitions. The forward slash in the Python function definition syntax indicates that the parameters before it are all positional only arguments. This means that those parameters must be passed by position and cannot be passed by keyword. Okay. So this kind of, dang it, this kind of gave us a little bit of a hack. So how could we do this? So we can obviously call, this is going to be total is equal to the sum. We need to sum if we sum data, what do we return? Let's see what we get here. Okay, we get a type error, meaning that int and list, so we can't. Christy asks, did you look up projects to work on or a project you came up with? Yeah, so all of the projects that I've made so far have been completely independent. I haven't used any, besides obviously the little, hotkey ChatGPT that I do, but I ask it to not really, I really heavily preface it like I do in my streams to not show me code so I can try to figure things out myself. Or if I've never actually been introduced to a method before, like my clear terminal, I didn't know where to start with that. So I started picking its brain, like how would I do it? And it ended up showing me like I had to use the sys and use it in this way. So I had to learn from it by example. But I had, the but all the projects I've made so far have been just all my own ideas, which has been a help in the fact that I've had to creatively think about it from a user's perspective for every instance, right? My programs are heavily tailored to user inputs for the most being. So I've had to, kind of rewire my thinking to account for those edge cases, which are oftentimes, which was heavily focused on in the CS50P course, which also kind of helped me there. The first project I made in my Harvard CS50P, which there's a demo on my channel, was a inventory tracker for, like, I used it for chemicals because I'm a chemist. I have to request a lot of chemical materials and manage them myself within my personal bin and make sure I'm reporting them and reporting the quantities used appropriately on the tags and for storage purposes in the chemical Kanban system. And so for all what I did previously was was making Excel sheets and tracking them that way and stuff. So now I have like a personal Python program that I can load in items and track, what items I have on my hand. And if I need more, I can load them in and stuff. So it's really cool that way. And then in my second project, I made a demo, which is where I leveled it up from the inventory storage system to a task tracker system where it had a lot of similar properties, such as the displaying of the creation and the storage aspect of these tasks, but not items anymore. They're tasks. But now I added like a date time element module to track the date as you go throughout. You have to open up the program in the future, and those tasks that have due dates have to shrink because you're further in time in terms of the days to complete them. Right, you're closer to the due date. So I had to import that, and then I also incorporated file saving and file writing, so I just leveled up from there. And now we're doing the small business manager, right, which takes a lot of similar properties from the task manager or the task tracker project, but the small business manager is just really going one step further by just being a lot more elaborate. Before we just were adding tasks and editing tasks, and then they would be reported out to us and filtering them out. But now we're adding items. We are converting items to transact them in terms of sales. We're tracking, data to represent, currency and reporting that. We're tracking those dates again, like we were with the previous problem. So we're just compounding these programs. We started with a small one, we compounded it to a medium, and now we're compounding it to a little bit of a larger one. And so, this one's going to take us a little bit to write, but once we have a working program here, we've gotten a lot. We've gotten the transaction started. We have all of the adding and the storage and the displaying, appropriately, and the recalling of items appropriately written. And so now we're moving on to actually converting those items into transact by giving them additional parameter updates and attribute updates, and then making sure those are saved appropriately. And so, yeah, it's interesting. And then I hopefully would like to use that CS50X course to then take this small business manager once I push the 1.0, which will be the CLI environment, and then I'll take this and I'll try to convert it into a more of a full stack application where the users can access it via the internet or through a web browser, and it can be, rather than just, or even make it like a desktop application with like a .exe, an executable file or something like that, similar to maybe like a Photoshop or like an actual real working desktop program. So yeah, those are the goals we have for the channel. So we're going to be using the CS50X course right alongside our projects live. Maybe I could even submit this as my final project for that course, and kill two birds with one stone. So yeah, so yeah, sorry, I've been rambling on. Because I want to start doing projects from a coding experience. Yeah, so I would definitely just find something that you do. If you like baking, like make a little um, like a recipe, like a holder. Like like think about it. If you like to cook, make like a little virtual cookbook. Like it houses all your recipes, and then you can pull them back up, and then it shows you all the steps, and maybe it will if you will wait for the user to press next to go to the next step to make sure, like for each recipe, so you can load up a recipe and then it walks you through step by step. That'd be a cool project, just thinking about it, right? Like rather than outlining all the steps there, it individually makes you insert them kind of like in a worksheet. Like, oh, you need to weigh out 500 grams of flour. How much did you weigh out? Oh, I weighed out 499. Okay, cool. And then maybe it does some calculations, and then you can give like a rating, or that'd be cool, like a whole mathematical based um, cooking system. Or let's say you like instruments. Maybe you can take a stab at making try to make like a plugin, like a virtual amplifier, or something to start getting into that audio realm of like audio engineering and stuff like that. Just try to find passions that you have and convert them into some sort of technological application, whether it be, and start really small. You do not have to rewrite the wheel. We're not Mark Zuckerberg here. We are just normal people. I'm a normal guy. I have a 9 to 5 job. I'm just studying this, and so we've got to start small, and we're gonna slowly build from there. And I think that there's this illusion that online and social media has given, that everything is so quick to be built, and that people, I learned to code in 2 months and I got a job. It's just so not real. It's just so not real. Yeah, you gave me an idea even though I don't cook. Yeah, like but I mentioned like try to find something that gives you a little bit of interest, because then it'll just make it that much easier to be willing to and wanting to sit down in front of your computer, right? If you actually have a little bit of a passion in it in your everyday life, it just makes it so much easier to be wanting to sit down and work on it. Well, hopefully that helped. Yeah, SD213. Yes, that was not going to work. We can't sum data here. So can we use like a list comprehension and be like some data for Well, my friend enjoys cooking and baking, so it can be helpful. Yeah, for sure. That sounds great. Like, yeah, just like a recipe follow along, or, you know, and then you can try to get that into like a CLI environment, and then maybe try to expand that into more of like a full stack, and try to get it into like a front end, and learn about that, and just, and just use it if it works and if it does something, great. But if it doesn't, at the end of the day, you still learn something, so there's value to be taken away from it. So we looped through this array last time and summed it this way. So we're trying, how can we use the sum function in this case? Obviously, we have a tracker here, or like a counter to keep counting, but we need to, obviously we can loop, but I think it's trying to elude some way that we can do this like trickily. But for the disk and server, it should be me6. Oh, okay, is that for the bot? So if we wanted to sum, we could, if I just copy this over and um, go like this, and rather than use a counter, right? Let's just say we want to sum for list and data, sum the lists, right? If we sum the list, the values of the list, are we going to get one? Are we only going to get the most recent value back? We get none. Because it's not a single object. Comprehension syntax. Yeah, so that's what I was thinking it might have wanted. So if we say total is equal to um, I'm really bad at comprehension syntax, to be honest. I need to get better at it. I need to get better at it. Did I call the function? Yeah, I called print sum matrix here. Oh, hold on. That might be why. No, we still get none here. Yeah, we still get none here. Yeah, because it was still pulling in our previous example, even though I had data here, it was still pulling the data from right there because it was locally, or globally defined above it. So it still worked in that syntax, but so it still works here. So how can we use the comprehensive syntax though? So we take in matrix. Mm. Oh, I'm not returning. That would make sense. Uh-huh. See, that'll sum the last list. It'll sum this one, I believe. No, it's going to sum the first one. So it's summing the first value of the first list that's in here. In matrix. we say yeah, so we still would have to use a count. We still have to use a count like we did before because like I assumed is it's only going to sum. I thought it would might have looped through all of them and summed and then reported the last one, but it looks like what it's doing is it's summing the first one and just reporting that value right back. So what if we so obviously we can say count equals 0 here. We can use sum of L and we can append this to count, right? Or concatenate it to count, and then we could just return the count at the end. And that'll give us the value we're looking for, 3620. So pretty much the same function as we wrote before, but we just, you know, rather than double looping here through every value after we seek it, we can just sum the list directly here. So, yeah, let's get caught up on the chat here. Is this still recursion? Chrissy says, is this still recursion? No, this is chapter 5. This was about arrays. It didn't specify directly that we needed to use any recursion for this, but I definitely think we could for sure, yeah. Um, uh, but no, this is just about arrays and lists and not lists, but using a list as arrays in Python and arrays-based sequences and understanding them. We moved past the recursion was chapter 4. Yeah, so this would be this function here. Cool. Yeah, I know that list comprehensive syntax for making a list comprehension. Yeah, and then you can also make like a mathematical element on that first value of x. You can say x like square x times x or x squared for x in the old array. Exactly. So I wonder like because I don't like to I often say don't show me code, but ChatGPT did try to spoil the answer here for us. We did it a different way though. We continue with our loops, but what they do is they say, um, this is what they say you could do for a list comprehensive syntax kind of. They say you can take your data list and you can say like total or whatever or count is equal to the sum of inner for inner in data. So you call a sum of the inner, list for every inner list in data, and then you sum those together. Ah, okay. So let's try to implement this. So if we were to do it this way, we could say def sum matrix. We'll say 2 here. We'll take in matrix. So for this one, we can just give our count is equal to the sum, right? We're going to take a sum of the overarching sum of the individual lists, right? For every list in our matrix, right? Just like that. So now if we and then we return the count here, right? And we call print sum matrix 2, right? For the data variable. And we run this. Boom, 3620. But it looks like we get it twice. Ah, why do we get it twice? Do we not need this extra sum? Oh, it's because we're printing here. Never mind. Oh, funny. Funny, funny, funny. All right, because we're printing it here as well. So we'll do that. Okay, see now, boom. 3620. We were calling the first function as well. Right? So what this comprehensive syntax is doing is we are determining a variable count, right, which is the total count of all these sums, value the total. We are calling a overarching sum, like an over umbrella sum, right? Think we are summing the entire. We have each of these arrays in our total array list, right? So we are summing the total array, but we need to sum each individual list for every list in the matrix, right? So we're going to sum each individual list, sum all those together, and then return the count. So the only thing that this does is it looks like it's probably the same. You call sum deliberately twice here on itself, but you would call sum multiple times. No, you'd only call sum once for every list and then return the count. So I wonder what the time effect would have on this by calling the sum function twice. Because the sum would have a secondary loop happening as well. Yeah, Airsick, yeah, we got that. We were printing twice. Yeah. Yeah, so this one did try to spoil it. Like I often say is whenever I ask prompts to GPT, I always try to tell it to me to say don't show code, and sometimes it'll even try to show me code. So I really like to just work off of the verbiage, and obviously sometimes it's not correct, so we have to take it with a grain of salt. But for the most part, it's definitely very helpful. You can also do count plus to equal list. Hey, Wing Hong, welcome in. Hope you're feeling better. I know you were down yesterday, but best wishes to you and welcome back. I appreciate you joining me. I appreciate you guys stopping in on Christmas. Yeah, awesome. And again, my camera is a little bit stretched. It's kind of bugging me when I go look at the chat. So I will fix that for the stream tomorrow. I fixed the overall resolution to capture my entire laptop screen from before. It was only capturing a certain chunk and it was making it difficult for you guys to see things yesterday. But now I need to just not do the scale and I'll have to just manually scale it up myself. Yeah, Airsick, I tell it to, walk me through things and act as a tutor, but the only thing is I'm not paying for ChatGPT, so it just doesn't remember my individual settings, right? It remembers my conversations up to an extent, but I think you have to get the paid version for it to really start to like remember who you are and what you want it to do. Because I'll often tell it to don't show me code and to act as a tutor, but after a few more prompts, it'll kind of reset back to its original state. It needs a little bit more work. All right, cool. All right, let's go ahead. And you guys want access to these notes that I've taken regarding chapter 5. All these, right? I did shift option V or shift option V. I made markdowns of all of my notes with coding examples from all the subsections within the chapters. This is the current chapter we're on, chapter 6. So we're on stacks. We learned about stacks, right? We started to learn about queues. So it's really cool that we got some good organized notes here. So everything right here is on my GitHub, and it's accessible there. So I'm just going to push this really quick. Git add, git commit the completed more chapter 5 reinforce. publish this. All right, cool. I thank you guys for joining me on today. It's really awesome you're here. For those that don't know, my name is Michael, or they're new. I have a bachelor's of science in human biology and a minor in chemistry, and I work as a formulation chemist for a Bay Area tech company or biotech company. And I've been teaching myself to code after my 9 to 5 job and on weekends, and streaming it for you guys here for the past few weeks and months. So yeah, I really appreciate you guys joining. Feel free to follow along to the channel. I do live reading and work throughs of these books, and also do live projects. And we're going to be doing some upcoming courses in CS50, the X new rendition. It's going to be really awesome. So I want to just quickly continue a little bit into chapter 6 where we left off last time. Let's see here. We need to keep going, you guys. We cannot let this information fade. We need to keep compounding on it in order to solidify it. I know we have this winter break for the holidays, and I'm at my folks' house in their guest bedroom here. But still, we need to stay dedicated, and we need to continue on with this and really solidify these concepts, because even a short couple of days, stuff can really start to fade away quick. Okay, so where are we at? We're at Q's, our abstract data types. I've already seen this one. Resizing, yes. Shrinking. Okay, yeah, here. We're at double-ended Q's, 6.3. All right, 6.3 double-ended Q's. All right. Technically, Data, thanks so much for joining and leaving a comment. I'm looking over at my phone for the chat because I'm on my laptop here. I'm not at my normal desk setup. We're on visiting my folks for Christmas. Are you learning to get into IT/tech? Yeah, I don't really know. I'm trying not to put too much pressure on it with like an overarching goal or desire. I'm mainly learning to just gain additional skills. I have a degree that I spent quite a bit of money on, and that I want to value, and I want to get some value out of it. I've been working as a chemist for the past 3 years, so I've been getting value out of it, and so I definitely have experience in this current field. And so if I can maybe intertwine the two somehow into maybe computations or bioinformatics or data analysis for whatever, so it could be very interesting. Maybe like reviewing or programming textbooks, or chemistry and science textbooks, or whatever. I don't even know. It could be really whatever avenue it takes us down. We'll get there when it comes. I'm really not trying to put too much pressure on it, but yeah, I currently work as a chemist, and so whatever happens, I'm just trying to gain additional skills here, and get a community going here on the channel. So thanks so much for joining and leaving a message. Appreciate you coming in. Right, and it also bump your pay. Yeah, it probably would have some sort of effect on my compensation too, right? Just, it's always a good idea to always, continue your education, take on additional skills. I think it's very normal for people to become stagnant after they graduate college, and um, you know, and think that, okay, I've done 20 years of schooling now, whatever it is, 15, 20 years of schooling, I'm done. But really, you're just getting started. Like you're just given all the tools, and now you need to start building the house, right? You need to start using those tools that you got taught how to study. You got taught how to, you know, do these different things, and so now you can do it on your own and be an adult with it. And so I'm trying to bring that kind of mentality back to it. Yeah, Angela Lopez says bio and data science are perfect together. Yeah, for sure. So if I can just keep showing that I can demonstrate my coding skills, I heard that I have a lot of people within the Discord and that follow the channel that are current CS majors that say that a lot of their classmates, can't code and don't know how to code. And I don't know if that's true or not. I'm just, hearing what you guys are telling me. I'm not in school, but if I can have a channel that can show that I could literally, it literally shows proof that I'm coding live here on my own and building projects, I think that could show value. And so I've actually gotten quite a lot of people reach out to me saying like, no, I want to start streaming too and doing what you're doing and showing my learning. And so that's great. I think that's awesome that you guys are, getting some inspiration from this and, wanting to maybe do something similar. That's so cool because you're just, working on improving on yourself, which is, you're supposed to be selfish. It's your life and you're supposed to, why not learn as much as you can? Why not become as smart as you can? Who's telling you you can't? All right, sorry for that ramble. 6.3, double-ended queues. We next consider a queue-like data structure that supports insertion and deletion at both the front and the back of the queue. Okay, let's quickly before we dive, we took a couple day breaks, so let's just do a quick review. So we're talking about stacks and queues right now. We first started with stacks and we understood like a stack of CDs or a stack of pancakes. You can't just arbitrarily take from any position in the stack. You're going to topple the stack. It just does not work physically. So it is a last in, first out, a LIFO method where the last item added is the first item removed. So like a stack of CDs, you can't pull from the bottom or it's going to fall over. So you have to start taking from the top until you get to the desired item towards the bottom or whatever. So there is that kind of effect with the stack. Now we learned a technique for um, we talked so the stack dot push, which is technically the dot append method, will add an element to the top of the stack. So the end of the list is the end of the stack or where things are being pulled from. The pop method just will remove that topmost element. We have a stack dot top, which is in Python, which is just the index to the negative first position or the last item, which just provides you a reference to the object in memory within the array, but does not actually remove it with the pop method and return that value to you within some sort of variable that you can assign to it. So the top method here, or in Python, is the stack at the negative first or last index point in the data array is the reference to that most accessible object. We also learned that the is empty, returns that Boolean expression for true or false. Returns true if it does not contain any elements, right? Length of the stack is equal to 0 in Python. And then obviously the length of the stack uses that dunder length special method within the initialization of the dynamic stack class or whatever that they implemented in Python because you had to make a custom class within Python to get access to the stacks or import a stack module. We learned that about stack running time. So the top is empty and the length. They use constant times. They just do it in evaluation is empty, like true or false. The top just takes a reference. The length, just takes in how many data points are in the memory. It's easy to return. But the push and pop we learned about amortized big O notation where within arrays are unlike lists. They kind of perform in similar ways, right? It's easy to intertwine the two, and they're often referenced similarly. But an array, it has a dynamic approach. It's not a what would you call it? In chapter 5 we learned about it. What was it called? Like a low level array or a continuous memory array or whatever. It was more of it was dynamically sized, right? So the array itself has a memory capacity of itself, and it is independent of the objects inside of it. The objects have references elsewhere within the system's memory that we pull and gather in this array in one central group. But the array, how it is sized in terms of its bytes or whatever, is the actual just number of positions that are available, whether they're filled or not. So as we increase the amount of elements or append, within that that push stack or whatever, it eventually we're going to have to run out of space and we're going to need to increase the size of the array. So that's what's going on behind the hood is we are dynamically increasing and decreasing the size of the array at various points when the array becomes full or becomes maybe close to full, or as we reduce by a certain number of elements and we have, if we have a fourth of the array vacant, then we will go ahead and shrink down, all based on those kinds of things. So it'd be like the length of the array with the floor division of four, right? If you know whatever type of mathematical operation you would do, or it would make it be like a module. I think it'd be a floor operation. Um, so yeah, that was interesting to learn about as well. And so, but overall, we have an amortized constant time, big O, because it's just kind of like the general average. The payment is paid for in advance by the appends. The appends are so fast and happen so quickly that it's kind of averages out, and for lack of better words, it used this old example of cyber dollars to prepay for the dynamic size increase on with each append. But just think about, the appends are so fast within the memory, within the process, that it kind of just balances out that increase in size, that it really kind of negates it almost and makes it amortized. Ties, tie, t. There we go. Wing Hong, amortize. Yeah, amortize. So that's what I'm explaining, right? So it's like an average. So you think of like with a car payment or with things like that, or with banks, you have an amortized payment schedule, where it's like the interest is averaged out over the course of the 12 years, or the 12 months of the year, over those 60 months of the contract of the term, right? So it's think of it like that. If you haven't any experience with, like, financial loans or anything like that, but it's just an averaged out kind of effect, because those appends are happening. The appends are happening, you know, way multiple times more than these dynamic size and decreases of the array, because we have to, obviously, if we increase the size by times two, we have to add double the amount of elements until we then get to that point where it's full again. So we are doing so many more append operations that it basically just kind of averages out or negates those O of n, you know resizing of the array. Yes, exactly. So it's just describing a word to describe time complexity, that's kind of pulled from the old, you know, loan and financial sector, I think, regarding, like, average payment, based on, like, it's really, yeah, they did a really, poor job, in my opinion, in this book, explaining with the cyber dollars. But they pretty much said that the appends are prepaying the cost ahead of time for those restructures of the actual array, and those copying of the elements over to the new array, because the appends are just so fast. Okay. Now, again, I'm learning this, you guys. I'm learning this live with you. I'm just reiterating, conveying my current understanding, of the text at this point in time. Now, this could be, uh, iffy. It could not be correct. So if things are not adding up and you guys have disagreements, feel free to cue in. I want to make sure I'm learning the right things and saying the right things. And but obviously, this is a peer-to-peer environment. We're equals in this, learning together. This is not like a teacher thing at all. I'm just kind of word vomiting here for my sake to solidify these concepts. I'm not like talking at you guys for this. Yeah. Okay. So then we learned about cues. So cues are just like a line, right? Where the first person in the line is the first person that then gets removed from the line. So it's the first in, first out principle, where, right? So you enter a line, you wait in a line for 15 minutes on a roller coaster, and then you finally get up to the front and you get to ride. So you pull things from the front. Now, I was confused originally about what direction things were being pulled from. Was the front of the line at index value 0, or was the front of the line at index value -1? Meaning, was the front of the line at the start of the list or at the end of the list? So from that example, so uh, it said that it mentioned it here. It said that it mentioned it here. See, it also talked about the circular arrays, using circular arrays, um, which were really interesting as well. I need to do a better job of going back and taking notes on the circular array part. Okay, so let's continue on here though. We next consider a queue-like data structure that supports insertion and deletion at both the front and the back of the queue. Such a structure is called a double-ended or a deck. Okay, so this is a deck, not a DQ. A DQ would be DEQUEUE. This is called a deck. A double-ended queue, aka a deck. Right. So I'm gonna do like this. Deck is a queue like data structure that supports insertion and deletion at both the front and the back of the queue. Right. Such a structure is called a double-ended queue or a deck, which is really pronounced a deck, to avoid confusion with the DQ method in the regular queue ADT, which is pronounced like the abbreviation DQ, disqualify. Yeah, DQ. Okay, the the deck abstract data type is more general than both the stack and the queue data ADTs. The extra generality can be useful in some applications. For example, we described a restaurant using a queue to maintain a wait list. Occasionally, the first person might be removed from the queue only to find that the table was not available. Typically, the restaurant will reinsert the person at the first position in the queue. It may also be that the customer at the end of the queue may grow impatient and leave the restaurant. We will need an even more general data structure we want to model, leaving the queue from other positions. Interesting. So we have these types of methods here. So the deck abstract data type. To provide a symmetrical abstraction, the deck ADT is defined so that the deck D supports the following methods. Okay, so we'll say like this. We need some examples here. Here. 1 and 2. So. Okay, and then we'll have, we need this part here. We'll say, the DQD supports the following. The DQ ADT is defined so that DQ, or sorry, the deck the deck ADT is defined so that the deck D supports the following methods. Okay, and then we'll go one. D dot add first with E. Add element E to the front of the deck. D. 2. D dot add last element E. Add element E to the back of the deck D. All right. I got some chats here. Angela Lopez, I have to go already 3 a.m. for me. Night, night. Have a nice session. Wow, thanks so much for coming in. I really appreciate you stopping in so late. That's really kind. Have a great rest of your day and Merry Christmas to you. Dig, how many hours do you study this every day? I usually try to study for at least about 2 to 2.5 hours. Sometimes um, I study for 3 plus. Like I said, I'm a chemist. I have a degree in human biology and a minor in chemistry, and I work as a chemist um, and a formulation chemist for more specific. But I um, I stream after my 9 to 5 job, usually around 7 p.m. PST, and I usually go till about 9:30 or sometimes 10:30, and sometimes even 11. So I put in a good about 2.5, 3 hours every day of studying for the past 3 weeks, and I've really improved not only my coding but I'm really quick. My brain is faster at catching my bugs, about catching I'm quicker about reading things and understanding. Oh, that's not supposed to be there. Understanding like exactly my bugs and my typos. I have a lot of I type fast, so I oftentimes have typos and I go back through and I'm able to catch them faster. I'm able to actually answer these questions that the book is asking me faster. I'm requiring less and less help because I'm actually compounding and practicing this material every day. But obviously, yesterday was Christmas Eve and today was Christmas, so I only did about an hour and a half, because just to be light. But I did. I'm in a different setting here. I'm visiting my folks. I'm in their guest bedroom, so I'm not at my desk. So it's a little bit of a different setting, so I can't really do too much. Hopefully that answers your question, I dig. I appreciate you joining and leaving a message. Yeah. Legendowski says, "Is it a Q or is it Q versus deck?" Yeah. So the don't think this is not a DQ, right? This is um a deck, right? It's pronounced deck. It's a double-ended Q, meaning that it can be removed at both the front and the back. A DQ is a different method of the actual Q ADT, where you can DQ someone from the queue, right? You can remove someone from the queue or whatever. The DQ method, I think, is the like what selects someone as the person that's next up, right? This is a deck, a double-ended queue. A DQ. So the DQ is just a method that's within the queue abstract data type for that process of just removing that next person that's up in the queue. You're DQing them. You're selecting them out of the. You're just taking them. Now you can't take them from anywhere because queues have to be taken from the front. It's first in, first out. So the DQ happens at that first place. The deck is a double-ended queue. Exactly. The DQ is when you select the person that's at the front of the queue to be removed because they are now their table's ready, or they can ride the ride, or they can whatever, right? But if you think about it, a roller coaster ride is technically a deck because people can get bored of waiting and they can leave at any time. They can just walk away. Um, so yeah, is DQ done with pop? Um, let's see here. Let's go back up to the Q data type here. So the DQ function will um, so the DQ will remove someone from the first element, first in, first out. So what it's doing is it has to obviously. What's interesting about this is it's a circular queue, so it's setting the values to none for garbage collection, because it's a circular queue. It's not like a singular list, which was really interesting. They talked about using arrays circularly. I need to take better notes on this. I need to go back through and do better notes on this. So the DQ method is actually removing. I don't think it's not taking any pop anywhere within this class actually, um, because it's using a tracker, because it's a circular queue, meaning that um, you know we don't want to run out of space in the queue. We want to be able to expand this queue and expand accordingly. And so rather than filling each value with none and expanding infinitely, we circulate those none values and replace them with new entries in the queue, in a circular fashion, so we don't just create arbitrarily large queues with tons and tons of none values, um, which makes a lot of sense, right? We fill in those none values circularly and with new entries in the queue and just keep looping through the queue. And then if we need to expand, we'll just expand the loop or expand the loop even further. Um, so what's happening is it's making a DQ off of an index. So it's keeping a track of the front, right, of the line via some sort of index tracking, right, that's happening, and it's removing um, that person from the queue or DQing them based on that front tracker. They're tracking the index of the front of this circular loop. So there is no pop taking place in this example here, but in which is a circular array or queue. Okay, we are almost done with this chapter, so let's just keep pushing here and let's try to finish the chapter before we call it for today. Okay, so number 3 is going to be the deck dot delete first with okay, no element provided. This remove and return the first element from the deck D. An error occurs if the deck is empty. Okay, 4, D dot delete last will remove and return the last from the deck D. An error occurs if the deck is empty, right? Number 5. Additionally, the deck ADT will include the following accessors. So we'll make a note here. Additionally, the deck ADT will include following accessors. Number 1. I'll say number 5, D dot first, return, but do not remove the first element of the deck, D. An error occurs if the deck number 6, D dot last. Okay, I'm gonna copy this. Return, but do not remove the last element of the deck. An error occurs if it's raised. 7 is D dot is underscore empty, which we return true if the deck D does not contain any elements. And then lastly, 8, the length of the deck. Return the number of elements in deck D in Python. Oh my gosh. We implement this with the special method dunder len. One, two, and then like that. Cool. You can try the deck library in the Python collections. Oh yeah, we definitely need to get some practice with the Python collections. Okay, example 6.5. The following table shows a series of operations and their effects on the initial empty deck of integers. So if we add last, we add 5. We add first, that adds it to the first of the first 0 index of the list. If we add first for 7, that inserts at 0. If we reference first, that references 7 but doesn't delete. If we delete last, we actually delete the number 5. If we take the length, well, this is going to be 2. If we delete last, that's going to delete 3. If we delete last, that'll delete 7. If we add first, we'll add 6. If we reference the last, that'll be 6. If we referenced first here, that would be 6 as well. If we add first 8, that gives us 8 in the 0 place. If we give is empty, well, that's false because we have elements. And if we reference the last, with the last reference, we reference the 6. Why do you need DQ when there are pop left and pop rights? The DQ pop left and pop right. Python doesn't have any pop lefts or rights method, does it? It just has a pop method. Does it have pop left and right? I'm not sure. Implementing a deck with a circular array. We can implement the deck ADT in much the same way the ArrayQ class provided in code fragment 6.6 and 6.7, so much that we leave the details of the ArrayQ implemented to exercise problem P6.32. We recommend maintaining the same three instance variables underscore data, size, and front. Whenever we need to know the index of the back of the deck, or the first available slot beyond the back of the deck, we use the modular arithmetic for the computation. For example, our implementation of the last method uses the index. We take the front plus the size minus 1. Self underscore front. So the front index value plus the size minus 1 divided by the length. Our implementation of the array add last method, array deck add last method is essentially the same as that for the array q nq, including the reliance on the resize utility. Likewise, the implementation of the array deck delete first method is the same as the array q dq. Implementations of the add first and delete last use similar techniques. One subtlety that is a call to the add first may need to wrap around to the beginning of the array. So we rely on a modular arithmetic to circularly decrement the index as the front is equal to the old front minus 1 divided by the length of data to get that circular shift. Because if this is equal to the length of data, well, that shifts us back to 0. The efficiency of an array deck is similar to that of an array queue, with all operations having an O of 1 running time, with the bound being amortized for the operations that may change the size of the underlying list. The collections.deck interface was chosen to be consistent with the established naming conventions of the Python's list class, for which append and pop are presumed to act at the end of the list. Therefore, append left. Oh, we do have stuff here. Oh, okay. In the deck modulo, it looks like, or module. The collections deck interface was chosen to be consistent with the established naming conventions of Python's list class, for which append and pop are presumed to act at the end of the list. Therefore, append left and pop left designate an operation at the beginning of the list. The library deck also mimics a list that is an index sequence, allowing arbitrary access or modification to using the dia index j syntax. The library deck constructor also supports an optional max length parameter to force a fixed length deck. Okay. However, if a call to append at either end is invoked when the deck is full, it does not throw an error. Instead, it causes one element to be dropped from the opposite side. That is, calling append left when the deck is full causes an implicit pop from the right side to make room for the new element. Okay. The current Python distribution implements collections.deck in a hybrid approach that uses aspects of circular arrays, but organized in blocks that themselves are organized in doubly linked lists, a data structure that we will introduce in the next chapter. The deck class is formally documented to guarantee O of 1 constant time operations at either end, but O of 1 end time worst case operations when using index notations near the middle of the deck. Okay. Cool, and that is the end of chapter 6. So we can move on to completing next time some reinforcement problems from chapter 6. So cool. So like the first one says, what values are returned during the following series of a stack operations if executed upon an initially empty stack? Okay, so we'll just, okay, that's cool. So we'll think about those, and interesting. All right, you guys. It is Christmas Day still for me. I'm gonna go spend the last little bit of Christmas Day with my family. Uh, so I am, like I said, I am visiting my family here for my parents for Christmas. I'm in their guest bedroom right now, but I wanted to keep the stream streak alive and keep it going for you guys. I wanted to show that I was consistent and that I'm dedicated here, and I really am passionate about this. So I really appreciate you guys joining me here. And yesterday, in the stream yesterday, the entire stream, we worked on the small business manager. So if you want to see the recent implementations we did to our actual project, go ahead and watch the stream from yesterday, which was Christmas Eve. But I'm going to just call it a little short today, um, because, ooh, did that not save? No, it did. Good. Okay. Yeah, so I'm going to just call it short today because it's Christmas, and I'll be back tomorrow. We streamed today for over an hour and a half, so a good Christmas stream. I wish you guys a Merry Christmas if it's still Christmas for you guys, or Happy Holidays in general. Stay safe. It was awesome having you guys here. Thanks so much for joining me. Bye, guys.